When we talk about regular exercise, say going to the gym multiple times a week, or doing yoga regularly, or cycling, or anything that's consistent, there often tend to be two extreme ends of people: those who absolutely love being dedicated to exercise, and those who completely hate it and refuse to move. There are those who dread waking up in the morning and actually performing physical activity, and then on the other hand, there are those who dread not waking up early and exercising. Clearly, these are different preferences, and we've often thought that that's kind of just how people are. But people have experienced, and previous studies have also shown, that once they start exercising, there tends to be a positive feedback loop and people tend to persist with exercise. A few days of exercise can actually get people who hate exercise to love it and take them to the other extreme. But it's not been clear how this cycle in the brain begins and what chemical changes actually occur in the brain. A new study of our brain's signaling networks has now revealed what happens in the brain when someone goes from hating exercise to loving it. In this video, we'll look at what the study found using a brain imaging technique and how our body's own opioids facilitate this. I'm Sandhya Ramesh, and this is Pure Science. For the study, researchers in Finland recruited 64 lean male volunteers to do a series of incremental cycling exercise tests and then answer a questionnaire. The volunteers' brain activity was observed using a medical imaging technique called the positron emission tomography, or what we commonly know as a PET or PET scan. It uses a radioactive drug, a tracer, that enters the bloodstream and which can be tracked as it moves through the body. The tracer is injected into a vein in the arm, and then it will start pooling in areas with high metabolic or biochemical activity. All 64 men underwent PET scans. 24 of them subsequently had another scan after a moderate intensity exercise session of an hour, and 12 people had another scan after a high intensity interval training or HIIT session. The participants then also completed a questionnaire that checked for moderate to vigorous physical activity and how many minutes a week they did it. The study found that higher self-reported numbers of minutes of exercise was a good indicator of receptor activation after HIIT workouts. These receptors in the brain are mu-opioid receptors, parts of the brain where opioids go and latch onto. Furthermore, the study also found that those who exercised more on a regular basis showed more activation of these mu-opioid receptors. Some people generally tend to have higher amounts of endopioids, or opioids that are produced naturally within our own bodies, and for others, the amount of opioids released naturally in the body can actually be improved with exercise. These opioids in our brain are related to regions that pertain to reward and cognitive processing. So the study basically found that the more someone exercises in intensity, the more opioids are released in our brain, making us feel good. And the more someone is trained to exercise, the more capable they are of releasing higher amounts of opioids, which act on the reward center of the brain, further improving and regulating mood. Now, when listening to this, you might think that this is already known. We already know that when we exercise, we feel better, we feel less anxious, we feel less stressed, and our mood improves. This then leads to us exercising more. We've already known this. The difference here, though, is one term that is associated with exercise, which is endorphins. Endorphins actually stand for endogenous morphine, which is the body's own morphine. Metabolized endorphins do bind to the mu-opioid receptor, but endorphins are associated with euphoria. This is the same association made with actual opioids like heroin or morphine. Consuming them the way that they're supposed to makes the molecules of these opioids bind to these very receptors, but this then ends up inducing a euphoria or a very, very happy high. These receptors are the body's gateway to actual drug addiction. Mu-opioid receptors mediate a positive reinforcement or a positive feedback loop through direct activation from drugs like morphine or indirect activation from substances like alcohol, cannabinoids, and nicotine. But this feeling of euphoria and feeling high or buzzed like after consuming drugs or alcohol is not the case with endorphins at all, unlike previously believed. The activation of these receptors with the body's own opioids actually leads to very subtle changes, usually just to mood stabilizing effects. In fact, things like extreme happiness after exercise and what is commonly known as runner's high, which were a very important part of the exercise discourse for the past couple of decades, are now considered a complete scientific myth. Runner's high does not exist, and most athletes never experience that feeling of intense euphoria after a long run. Instead, they just end up feeling extremely drained and tired, even nauseated and feverish, as inflammation starts to occur in the body as an immune response to stressed muscles. Additionally, endorphins do not cross the blood-brain barrier. Instead, endocannabinoids do. In experiments where endorphins were blocked, people who exercised have still experienced general mood improvements, which now, after the study, we understand is thanks to the activation of these mu-opioid receptors in the brain. The study also found that the fitter a person is or more trained they are in exercising, the more capable they are of activating these receptors for mu-opioids and producing more endo-opioids. So this definitely improves mood the more we exercise. Ultimately, what the study has found is that regular exercise training and higher aerobic fitness induces neuroadaptation in the brain, which we knew already. But now we understand where and how. It occurs in the MOR system or the mu-opioid receptor system. Instead of focusing all attention on endorphins related to exercise, the study showed that exercise changes the MOR system itself thanks to other endogenous opioids in our body other than endorphin. This in turn improves emotional and behavioral responses, and this association persists and improves with long-term exercise. In conclusion, people who exercise more and regularly have better control over their mood and behavior on a daily basis.